All right, what I'm going to do here at the start is different than just about ever do any class. Is what I'm going to briefly do is walk through the types of problems this page. I want to remind you that on the back of your packet, right before the formula chart, you have a little cheat sheet. Let me pull it up. Here's your packet. If you go down right before the formula chart, you have this cheat sheet you can look at that describes to you the test you're about to see. That I can't quite see the whole thing. Let me minimize this a little bit more so you can see everything. Yeah, you can use this for a moment. It's going to describe the types of problems. You're going to have 28 questions. You take the test next time around. You're going to have 28 questions. 2 of them are what they call enhanced problems. I will show you. I made a bunch of examples of this. I'll show you this in a second. But you're going to have 28 questions. I break them down into 6 types. And so without just reading this verbatim, I'm going to ask you, if you see the word parametric, what do you remember to try to do? Yeah, see the word parametric, what do you do? There are 2 ways basically to do all of them. But what's the recommended way for you? To grow a graph entry. And within graph entry, you're either going to choose parametric or relation. And relation you use if they give you only the x and y. Like it's only an x, it's only y. Parametric you use if they give you x equals with a t, y equals with a t. So I made 2 examples of this. Okay, so I told you I'm going to go real briefly through the packet, and then I'm going to get to what I'm going to call the oh shoot page. Jill might use a different word, but I'm going to say oh shoot because that one won't give me any trouble. So the first one's an example. When you look at the equation, do they give you both an x equals and a y equals? No. So this one I would not use parametric. I would use relation. Because it would relation, what you can do is you can take this part before we know what t is. It tells you what t is. And in this equation that has a t, we could substitute right there. My pen went out. Let me try this again. Let's see here. Is it back working? Let me check. Oh, wake up. Okay, we could just substitute this in for t as a relation. So let's go ahead and do this real fast. I'll just show you. Hopefully it's not still up on from my last class. Yeah. Okay, what I'm going to do here is go to new document. Don't save. Because I want to make sure someone did it last class in your calculator that you get to do this from fresh. I'm going to choose graph, menu, graph entry, and instead of using parametric, because parametric, you're either going to do it as parametric or a relation. I'm going to use relation this time because I don't have both x equals and y equals. If you were to choose parametric, you would need to have your x and y equation, which you could do the algebra of solving for y, but I want to get away from that. So what's the other way? Choosing relation. The equation is x equals 3t. I'm going to type in x equals 3 under relation. But instead of pressing t, what are we going to put in place of t? Yeah, do square root, fraction, 2y minus 8 divided by 3. Press enter. Now what I want to show you is the easiest way from here just to see which 2 graphs can we eliminate. I want to say A is out. It looks like it curves up and to the right, so A and C are B and D. What you can do to make sure, you see how this axis goes from -10 to +10? Make sure yours goes, you see how it says -10 to +10? Okay, and then if you look at the bottom of the graphs, it says -10 to 18. And honestly, they messed up. This says -10. It's actually not -10. You see how they're counting by every box is just 1? That's not actually a -10. What should it say? -2. So I'm going to change this one. Just double click your number, put -2. And then the top number, put 18. Now it should look exactly like, the shape should be exactly the same because we set our window to be exactly the same. Which graph would it be, A or C? It is A. How can you tell? Because A curves where it's just this end right here is just to the left of the top right hand corner. This one's down and to the right of the top right. So look at our top right hand corner over here. There's the top right hand corner. We're just to the left of it. So it's A. A is the correct answer. You're wondering why did it not show me the left side? That's the old rule about square roots. Do you remember this first semester here? What's the rule in square root? It can't be positive, can't be negative, can't be zero. What was the square roots? Can't be negative. Since it's x equals, the x can't be negative on this if you get a square root graph. That's why square root doesn't show exactly the same. Okay, so that's one way you can do parametrics is by a relation. Number two, we're not going to graph all these. I'm going to go quicker here. Check out, problem number 2. When you look at problem number 2, tell me what's different this time when you look at the equations. They have an x and a y. So this time I would not choose relation. What would we choose instead? I'm going to go to new document. This time, if you were going to do it by hand, you would choose menu, graph entry, and choose parametric because it tells you x and y. Cool on that? Okay, I'm going to skip from number 2 to number 3. I'm not going to do them all because that would make a really long review. I don't want to last day just overwhelm you with math. So I'm going to number 3. Number 3. Now that we're thinking on what are they giving me, it says the word parametric. You're either going to graph it as a parametric or you're going to graph it as relation. Here's my question. How would you graph this one? I'll give you 5 seconds just so everybody can think on it. 4, 3, 2, 1. This is a relation. Why did you choose relation? That's right, you graph that as a relation. You can test all the answer choices. You can just test them all out. I tried this x with this y, this x with this y, this x with this y. That would take a little bit. So to solve a little bit of time, what you could do is use my other equation they gave me and solve for x. This would cut off half of them. If I got x, if I solve this one for x, what would you do first? Good. So I'm showing you, you could do the graphing, but if you wanted to save a little time, this is the algebra you could do. This is the second way, if you will, to save a little time. And now, what's the opposite of multiplying by 2? Okay, so if you did this, you now got x by itself. Which answer choice is that? So now you could go to parametric, and you could try that graph, and then try C, and if C doesn't work, try D, and if D doesn't work, try E. And you could just graph and check and see which one overlaps the relation. Okay, I'm going to move on. Like I told you, I'm going to try to make up time. So that's how you do this section. All right, what do you see? What word do you see in the problem? Parametric. What's our way, the easiest way of solving parametrics? Relation or parametric and graph. Great. All right, what do you think, Jermaine? I'll give you a few seconds to think. What one would you choose for that? Relation or parametric? 3, 2, 1. Relation. He's right. Why did he say relation, do you think? It's no, there's no t, it's just a y and an x.
So we don't use the other one?
We will, but this part would be parametric. So the first one that doesn't have a t is a relation. You would graph that. Well, let's just go ahead, just to make sure we're clear. I can't remember if I'm on a new document. Somebody go new document, graph entry. The first one is a relation, menu, graph entry, relation, y equals 1/6 x squared plus 4. Hit enter. That's the graph you'd be looking for. Now for the answers, these are parametric because it's y equals with a t. So go menu, graph entry, parametric. And let's say we wanted to try A first. I would have 1/2 here, t squared plus 4. Now that would be the first one. I would need to find my y, which I don't have. I'm sorry, I needed to find my x. So what I would do is I'm going to kind of mold my way into the second way of doing parametric. If the algebra is solve for the shared variable. What variable is shared in these two equations? They both have an x. So I would solve for x. How do you get x by itself? Multiply. Good. Why'd you say multiply?
It's the opposite.
It's the opposite of dividing. So what does x equal?
X.
3t. So we plug that in the calculator as the x equation. And we know x has to be 3t. That's the part we know. We just don't know which one's the y equation. Is that the correct graph?
No.
How'd you know?
They're not.
They don't match. So I'm going to change this. Let's try answer choice B is 1/4. So I'm just going to change that to a 4. Is that the right graph? No. Let's try answer choice C. Is that it? It's going to be D then. Does that match? We found it. Okay, we good with that? All right, great. What if they're the real world problems? So 5 and 6 were the real world problems. How do you know these are parametric? Because they won't say the word. It'll give you a time value. So 5 uses the word seconds, and 6 uses seconds as well. So where do you get equations if they don't give you equations? Projectile motion. Go to your formula chart. Go to your formula chart. Oh, I forgot to clear this off the last class. Okay. Go to your formula chart and find the side where it says projectile motion. That's where you're going to get your two equations. These two right there. Those two are my equations I'm going to use. What I would do if I were you is I would stack them on a piece of paper. I would have a separate sheet of paper, stack my equations, and I would leave one line in between the two equations so you can plug in the values one time because they share a lot of values. So on this one, I'm not going to graph it, but I will tell you on this, if it uses an x and a y equals, this would be what type of graph, relation or parametric? Since they're two separate equations with a t, you would choose parametric, and you would plug in, what is your v0 on this problem? The initial velocity? 100. Okay, let me switch colors. What's my angle? Whoops, switch colors. Angle is 50 degrees, okay? We need to know gravity. Now what's important is to check your units all the way across. We're in feet on this problem.
So 32.
So when you come over here, it's 32 because that is in feet. Great job. That would be 32. And then finally, h0. The h0 is the initial height. What's our initial height? 4. Now, one thing I would add to this is I would graph that as parametric. On this one, I do have relations I would add to see if it's a home run or not. So it says the outfield fence is 300 feet away from the batter. Let's do the best I can to quickly draw this. I'm a great artist, as you know. Fantastic artist. Ball goes off. We want to know what's going to happen with the ball. It says the fence is 300 feet away. This is a 300. What type of variable would that be? An x, a y, a t, an h, a theta. What is 300? It's a horizontal line, so what is that?
It's x.
Okay, now that would be a relation because there's no t. It just says x. That's a relation. We're going to graph that as relation. And then what about the fence is 10 feet tall? What would that be? Okay, if we type all those in, I'm going to drop this. I want to make it bigger so you can see what I'm doing. So when I choose the calculator here, I'm going to go full screen like this so you can see what I'm doing. And I'm going to do it just to go faster. You would go to graph. How do I get to parametric? Parametric. The equations were x equals t times 100 cosine 50 degrees. And then the y equation was t times 100. Instead of cosine goes with x, what goes with y? That's right. You learned something? You know that sine is y, cos is x. We said 32 was gravity. And that's feet per second squared, so that's why the time is squared, plus 4 original feet. I'm gonna press enter. That's gonna be the flight of the ball. Now I'm also gonna add in here a relation, two relations. When you go to graph entry, I'm gonna choose relation. Why is it not doing graph entry? There we go, relation. And I want to put, we know the fence is 300 feet away. So that was next. We know the fence is 10 feet tall. So what's going to happen is I'm going to use that same trick I just showed you. I want to know what happens to the ball at 300 feet away. I'm going to just pick a number that's bigger than 300. I'm just going to say 325 feet. Be quick. And I know the ball is going to go up in the air. I'm not worried about negative distance. I'm going to just say, I don't know, 30 feet up in the air. So you can see the graph. Okay, tell me here. Let's see if you can interpret this right. I wish I knew how to hide that. I'm going to go a little bit taller so you can see more of the ball. Let's go 60 feet up in the air. Wow, how tall does this ball go? There we go. Okay, there's, so you can see what I just did. I just made the fence a little bit beyond 300. Oh no, let's move that. Well, darn. Trying to move the red out of the way. Which one's the ball? Which graph is the ball? There's 3 different graphs here. There's a blue line, there's a blue curve, there's a red line, and there's a black line. The blue is the ball. What do you think the red represents? The fence. Now, does that fence actually go up in the air forever like that? So where should the fence stop? It should stop at the black line that says y equals 10. That's where it stops. Now look at the blue ball versus the red fence where it stops at the black line. Is the blue ball above the fence, hit in the middle of the fence, or is what happens with the ball? What does the ball do? So this fence, what I was trying to do is move this. I wonder. The black line's the top of the fence. That's how tall the fence is, but here's the fence itself. So the fence should stop at that point right there. That's where it stops. What does the ball do in relation to this fence that's right here? You see how the ball goes higher than the top? That's the top of the fence right there. See how the ball goes over it? This would be a home run. Some examples of what would it look like if it hit the fence would be like this. Hits the top of the fence. You see how that's now hitting the very top of the fence? Here's an example of the ball hitting near the middle of the wall. Now the ball hits the middle of the wall. Here's an example of if the ball were to hit the ground before it reached the wall. Let me slide this just a little bit so you can see how the ball now hits the ground. This would be the ground. The x-axis is the ground. Hits the ground before the wall. So those are the different ways you can see that. But what I just did is I graphed it and I used a relation for the 300 and the 10. But either way, that's how you can do those problems. Okay, there's parametric in a nutshell.